Good morning. Today is Saturday, November 13th. My name is Ben Marles, and I am doing a podcast for Javier Rivera's 1:15 p.m. Uh, class for physics. Today I'm going to be discussing the buoyancy and density of different objects in water. If you haven't seen, I have uh, a half soda bottle filled with a certain amount of water. And we're going to be testing different objects, such as Tums Chewable, a cough drop, Advil, four of them, and some Pepto Bismol. Not exact on it's 5 milliliters. All right, so this water. Its density is 1 gram per meters cubed. Basically, that's saying it weighs 1 gram per every meter, and meter, as in 3 dimensions. Uh, what makes water interesting is it's the only solid that floats in its own liquid. Being that if you take ice or if you take water and you freeze it into ice, and you put it in water, it'll float rather than sink. Which if you were to do that with milk or let's say iced tea, it wouldn't. Or it might with iced tea because iced tea has water in it. So, but with any other liquid other than water, if you were to freeze it and then put it in its own liquid, it would sink. That's because for some reason the density of water weakens or lessens when it freezes, but it also has to do with hydrogen bonding. Water molecules like to stay together. They do not like to separate, which is why if you were to jump off a bridge from 100 feet high and land in water, you would probably die, or off of a major bridge. So let's get started with this. All right, first we're going to test the Tums. See also how long it takes to dissolve. All right, so ready? All right, so first say, a single Tums has a greater density than water, which means it has to be more than 1 gram per meters cubed. All right, now while that's dissolving, we're going to be testing Advil. We have 4 different pills. We're going to throw them in there. Those 2 seem to have a bit greater density than water. So while we let all that dissolve, time for the cough drop. Again, more than water. Alright, so now we have a separate tank, or separate bottle, for the Pepto. Let's test that out. Pepto does like to stay at the bottom, so it's more than water. Now, let's see if we can find an object other than ice that will float. I will be right back. So an object that I found is a simple bottle cap. Let's check. As you see, it floats while every other object in here sinks. It's because its density is less than 1 gram per meters cubed. Alright, so, and again, explaining why certain things happen with water. Again, let's recap. water is 1 gram per meters cubed. Anything less than water will float, meaning it has buoyancy. Anything more than water will sink. It won't even touch the surface, it just sinks. In the case of Pepto-Bismol, it's a liquid, so of course a little bit's gonna float. But the reason that an object will float or sink is dependent on its buoyancy, or not buoyancy, density. Well, actually both. But I will explain here with another Tums. If you take a Tums and cut it in half, its density will not change. The density is true for the whole thing. Alright. We have half a Tums. Going back in the same thing. And it still sinks. As you can see right there. Now let's take if we do a quarter of a Tums. As I'll do this in real time. Let everyone watch for themselves. We have Tums. It sinks. Now let's do that if we try an eighth of a Tums. No matter what, it's still going to sink. That's because the density throughout stays the same. As long as you cut it in half, the density of each piece will stay the same because it's the amount of mass in the object divided by the volume of the object. So if we take another Tums, compare it to the 1/16th piece of a Tums, you will find that throughout the entire thing, its mass will stay the same. What you want to do is you want to take the mass of the object and you want to divide it by the volume, which means the amount of mass inside the size of the object. It's a direct proportion to each object, and that'll give you the density. We're describing density as little d in this situation. Basically, that's saying the mass in here is going to be the same as the mass in here because the sizes differ, but the amount of matter is the same. So, or if you want to put it another way, you have this equation. Mass of larger object over volume of larger object is equal to the mass of the smaller object over the volume of the smaller object. If the objects are the same. So again, reiterating myself, the value or the density of that is equal to the density of that. Not exactly, but by ratio. So that does it for my podcast. Again, my name is Ben Marles for Javier's 115 class, and thank you for watching. Bye.